Somewhere near the center of our galaxy sits an object 4 million times heavier than the Sun. It's so dense and its gravity so extreme that not even light can escape it. This is a black hole, and figuring out what it actually is, how one forms, and what would happen if you fell in, is one of the strangest journeys in all of science. I'm Mr. Sticklab. Today we'll find out what a black hole really is, how one forms, and why the laws of physics break down at its center. And it all begins with a dying star. Every star is a constant tug-of-war. Gravity is forever trying to crush it inward, while the outward pressure of nuclear fusion pushes back. For millions of years, the two stay perfectly balanced and the star shines. But fusion needs fuel, and eventually the fuel runs out. The pressure drops, the balance breaks, and gravity finally wins. What happens next depends on the star's mass. For a star many times heavier than the Sun, the ending is violent. The core collapses in a fraction of a second, and the outer layers rebound in a colossal explosion called a supernova, briefly outshining an entire galaxy. But if the leftover core is heavy enough, nothing can halt it. It keeps collapsing, past every known limit into a single point of infinite density, a singularity. Mass bends space itself, and the heavier it is, the deeper the bend. A singularity bends space infinitely, forming a kind of bottomless pit. Get close enough, and the speed you'd need to escape climbs past the speed of light. That invisible line is the event horizon. Cross it, and nothing, not a rocket, not even light, can ever get back out. But there's no wall there and no warning sign. To us watching from outside, anything that falls in appears to slow down, turn red, and freeze at the edge forever. Yet the one actually falling in feels nothing unusual as they cross. It's simply the point of no return. And from outside, the region beyond just looks completely black. Keep falling, and gravity pulls far harder on your feet than your head. The difference stretches you into a long, thin strand and squeezes you sideways, an effect physicists genuinely call spaghettification. Near a small black hole, it shreds you before you even reach the horizon. But near a giant one, you'd slip past the point of no return long before you felt a thing. Black holes come in wildly different sizes. Stellar ones from collapsed stars are a few times the mass of the Sun. Supermassive ones sit at the heart of nearly every galaxy. Ours, Sagittarius A star, weighs 4 million suns. The largest we've found, ton 618, is 66 billion. How they grew so enormous, so early in the universe, is still a mystery. And black holes aren't truly eternal. In 1974, Stephen Hawking showed that they slowly leak tiny amounts of radiation and lose mass over time. For now they only grow, but in the far, far future, a black hole could shrink and vanish in a final burst. What happens to everything that fell in remains one of physics' deepest puzzles. So a black hole is a dying star collapsed into a single point, wrapped in an event horizon where even light is trapped. It warps space, freezes time for anyone watching, and stretches whatever falls in. That's what a black hole is. I'm Mr. Sticklab. The universe is stranger than you think. Stay curious, and I'll catch you in the next one.